Hello, everyone. Welcome to the FedEx Institute of Technology and to the Memphis Theater, or the Methodist Theater in specific. We're glad to have you. I know that we've got people from the general community and from the university. Let me know if you're not from the university. Fantastic. Welcome on campus. We're super excited to have you here. Today is going to be a really interesting topic that is applicable to everyone because it's in healthcare, and we all want to learn more about machine learning in healthcare. Well, I'll let you guys make an introduction in a second. But before we do that, my role is the managing director of the Institute. I'm brand new to the Institute in this go around, but actually in a prior life, I helped launch the Institute back in 03, 04. So I'm super excited to kind of come home, if you will. And I love what's been going on in the last 20 years and look forward to the next 20 years. And with that, I'll turn it over to Dr. Speaker.
Hello, good afternoon, everybody. And thanks for coming. We have a great speaker today, and this is a big thing. I'll just only he has many hats on that. He's a professor. He's one of the top schools in India, from Jadavpur University. I think one of the oldest school also, similar to one of our Ivy League schools. So, and he's a frequent visitor to US. Currently at Stanford, I think for 4 or 5 months he was there. So I had the opportunity to invite him here to give this talk. And the interesting thing is that you all know AI is booming and everybody's speaking about AI. And one of the important area of AI application is healthcare. That gets funding. And they start trying to cover that. And among many things, he's a fellow of 5 different organizations, IEEE, ACM, and many others. Then more than 400 publications, some startups, 25 doctoral students, among many others. So with that, I'd like to invite Dr. Ujjwal Maulik to give this talk. Thank you.
Hello.
I may not use that.
So that is better. We are basically teachers. We speak. Always we are more worried about the last bench. And in my school, I was among the top bench, front bench, and then I realized I was one of the foolish students. And those who used to sit on the last bench and used to go to the movie, all of them are in USA and they're big professors now. First bencher only stood faster, and that doesn't mean anything. Okay, so I will tell you that story throughout because all my students nowadays telling, sir, what is a paper? And if you can write a paper and that paper can generate at least $100, it's meaningful. Otherwise, why are you writing in the trash? So all these young generation have a different idea. Okay, so I will go through that, but I think there are a lot of students, so I will talk about very basic, and then slowly I will show, how things are developing over the time and what are the scope, huge scope, you can apply AI everywhere. So let's start from very basic. So fine, I will go like that, but forget about that. So let's talk about AI. It's a buzzword today, but if you see very carefully, this is a very old term. It is there for a long time. Even Turing also, 1950, he talked about that. If you have 2 machines or 2 men or 1 computer, 1 human being on the one side, and on the other side, there is the interrogator, correct? And there is obstacle in between. And interrogator started asking the question. Okay, definitely you cannot ask in voice because then the human being will understand. So you need to give it a written form. And from the answer on the opposite side, if you cannot distinguish between the machine and the man, then the machine is called intelligent. So that was the conjecture, Turing conjecture, long back, correct? So a machine is called intelligent when it behaves like human being. So we know it for a long time. And there is a very famous Turing test. And only very few passed. I think one Norway robot, he passed that. And recently I heard that ChatGPT also passed. Okay, the score, you need to do some scoring. And if you can do that score, only then you will be, people will think that you are intelligent. Okay, so that is Turing conjecture, correct? But why today the scenario is much bigger, correct? So AI is the whole thing, and in between there is a part which called machine learning. I'll come to that. And what people mistakenly does, they talk about machine learning and AI, but machine learning is a part of that. And then deep learning, last 15 years, everybody is jumping into that without knowing what is it, because to use that tool you won't have to know anything. Just I was discussing, until and unless you do the maths, it's very difficult for you to develop a new tool, correct? So whole thing is called AI, and machine learning is a part of that, and deep learning is even a sub part of that. And what is AI? So when I started almost 30 years back, I was a student like you. My class, my teacher used to teach me this kind of predicate calculus, correct? And then assume that you have a predicate calculus one side and you have a database, correct? So our time we talk about SQL. Now you are talking about MongoDB, correct? So you have a rule and you have a database. Using that too, you can generate all new and new information, correct? So that's AI. But that is not intelligence. Why? Because in this way, a machine is not learning anything. So correct. So this is a typical AI where you can use rule-based along with database. Today people talk about MongoDB. Our time we talked about SQL. So you can join that to, you can generate new information. Definitely that's AI, intelligent. But machine, by doing that, machine is not learning anything. Then why will tell machine is learning something? Assume that a small kid is there. You're showing a small kid a red ball for some time and green pen. So maybe after 1 week, you show the kid a green ball and you will be able to see that he is understanding that. That means as soon as he saw the ball, he has a concept of the topology and then two color, one green and red. So immediately he can correlate or she can correlate. So that's called learning. Okay. So it's a computer vision problem. So a machine, if a machine does that thing, you will tell it's learning something. Correct. So AI, machine learning, definitely AI, but all AI are not machine learning. Okay. Machine may not learn something. But if you talk about machine learning, I am working in this area almost 25 years. So you can divide, there are different ways you can divide it. But one way is like you can talk about unsupervised, supervised, and in between there is in between semi-supervised. Now let us take a very easy example. So I take a master's course on that, so it's easy for me. So what is classification? We are talking about supervised. So assume there are in this kind of room there is 100 people. We talked about Indian and German because Indians are generally thin and short height like me, and Germans are more taller. And I spent huge time in Germany in the last. So I know all my friends. They are very tall and okay. So if you have 100 people and then somebody asks you to classify into two groups, so typically it's called classification problem, correct? So how many groups you are talking about? Two groups, okay. And now this is a pattern recognition problem, what you talked about machine learning problem. So as soon as you encounter this type of problem, first thing you need to know what is your underlying data or data mining problem, or data mining or data analysis, whatever you call. So what is your data? In this case, a human being is the data. After some time, if you want to classify an image, then maybe your pixel will be the data, image pixel. And we work quite a lot in biology. So there we talk about biological cell and gene. Then your data will be gene. Correct. Today, if you want to forecast the weather, if you do the weather forecast of Memphis, then your data is weather data. And temperature, pressure, humidity, blah, blah, blah. Correct. So you need to be very careful what data you are handling. Okay. Here we are handling human being. Correct. So every human being is a data or pattern. They are synonymous. Okay. So you know already that. And knowing that, and you know there are two groups. So as soon as you identify your underlying data, next important task is what is the property of the data? That is very important. And this property is also called in machine learning or pattern recognition way or called feature. Okay? Database we call maybe attribute. Okay, and in maths we call dimension. Same meaning. So assume for this case, maybe you talked about 4 such features: age, maybe height, gender, and weight. Now look very carefully about the 4 features. Out of that 4, is age a good feature? Answer is no. Correct. You cannot differentiate a German from an Indian with age. You cannot have a rule like that. More than 40 is German, less than 40. So age is not a good feature. So you can simply remove that. Similarly, gender. Gender is not a good feature because you cannot have a distinction between male and female, correct? So, but it may be important for some other classification problem. So now, if you have n number of features, and from that n you pick up m, where m is a subset of n, this is called feature selection. Right? You have so many features, you picked up the best features, and then if you do that, so what will happen? You have two features. Assume, I mean, it can be different, and then basically your 4-dimensional data mapped into 2-dimension, and you need to do the classification in 2-dimension. Then the basic logic is you will be doing like that, correct? So you can expect that Indian will come into the low height. This is height and weight. So lower dimension Indian will come and German will come on the upper dimension. So basically what you are looking for 2-class problem, you are in 2-dimension, you are looking for a line, correct? This is called decision boundary. In 3-dimension, it could be plane. So you can argue why I'm talking about line, because line is very easy. Okay, if I have some other surface, it is not easy to find the equations, correct? So multi-dimensional, you can plane. So this is the equation of a plane, or in 2-dimension, it's a line, correct? So you can see is the equation of a, on the left hand side is the equation of a multi-dimensional plane, and 2-dimension we know it's y equal to mx plus c. That means for a, I mean, any classification you are trying to do, so you need to find the m and c, and if you can find the m and c, your task is done. Now for a supervised, so as already mentioned that out of 100 people into find Indian and German, assume that you already know these 15 are German and these 25 are Indian. So that means out of 100 training data, out of 100 data, you already know the class level of 40 data, correct? And knowing the 40, you want to predict the class level of next 60. So this 40 whose class level you already know before running your algorithm is called training data, and the rest are called test data, correct? Fine. So easy. That means you have a teacher. Training data is like your teacher. Okay. So, and that for using the training data, you need to find this m and c for 2-dimension. In multi-dimension, in n-dimension, you have n minus 1 and 1 constant. So your idea is all training data will help you to figure out that. That is true for any classifier. Okay. Any classifier used. Fortunately, when I was doing my first postdoc in University of New South Wales, I used to sit next to Ross Whelan's room. And Ross' PhD thesis was decision tree. Okay, what is decision tree? So decision tree try to find the most important feature, next important feature. Basically, they see entropy from the training data set. They try to find the entropy and some mutual information. And using that too, it try to generate a tree. The top you have the most important feature, next important, next level, and so on. So this is decision tree. So our time when I was a student, it was very popular. The algorithm is called C4.5. But then last 20 years back, we have another very important classifier called support vector machine. The idea is that you can see that if two classes are separate, well separated, how many decision boundary you can draw? Infinite number. Because non-overlapping. So you just change a little bit m or c, it will change. So you can do infinite. But the best can be found out by support vector machine. Okay. So I'm not going to the detail of support vector. In my class I teach. Just see it. So in support vector, they try to find the best one. Okay. What they do, you generate any decision boundary in the middle, then you find two parallel lines to try to separate two parallel lines until and unless they touches the first training point, and you can do it in every direction, and the direction which will give the maximum width, that is your actual classifier. So that is the principle of support vector machine. Okay, but every time you are depending on your training point. All those 40, like 25 Indian, 15 German, they are helping you to find it. Correct? So, and today you even decision tree, if you recursively call it, it become another classifier. So many you can have use neural network. You can use base classifier, which is basically conditional probability. So all these are, I mean, in the literature. Then another thing is, so this is about supervised, and what is unsupervised? It is also called clustering. That means I know there are 100 people, but I do not have any class information. So it's more difficult, correct? It's more difficult. You do not know who is which class, correct? Then what you can do, assume, let us think about 6 data point. How many features? 3 features. Assume age, gender, and food preference, and then assume you have 6 point: grandfather, grandmother, father, mother, son, and daughter. Okay. Now you see you are doing the classification on the basis of only one feature. Forget about multiple features. So how many classes you can expect? 3 classes. Because now I'm talking about the age, and it is expected grandmother, grandfather will be close to each other. So you see here, basically what you are doing, you are trying to put the point which are close to each other in the same group. So that is called clustering or partitioning, right? So there are so many algorithms. I mean, you have mean algorithm long back, 50 years back or 60 years back, just proposed DB scan, and in this area we have lot of we also propose lot of algorithms. But I'm not going into that. And you see that, I mean, if you go to the gender, again you expect 2 classes, and sometime what may happen, even with one feature also, it may happen like you go to the food preference, it may happen that you may have 2 cluster, but it can be overlapped. So clustering is very general, even with so little point. Now, why people do clustering there? The answer is, now first thing is that if you have a no training data, assume that I am giving you the weather data of this city, Memphis, for 1 year, and then ask you do some data analysis, out of which I can learn something and I can do some business. Then what will do? Class 8 to 10, maybe you will find mean temperature, mean pressure, mean humidity. Then you go for median, then standard deviation. What standard deviation mean? So in some day, if your temperature standard deviation fluctuate quite a lot, that means you can expect it may be a storm. So even a little bit of statistics can help you. And then if you do not have training point, you can do this sort of clustering. And what is clustering? By chance, if you see your someday in February and someday is May, almost close to each other, let us talk about 3 features: temperature, pressure, humidity. Then it's a surprise, because what do you expect? I do not remember Memphis. Kolkata, February are relatively cold and May is very hot. So we do not expect that these two matches each other. So that is surprise thing. That's the reason it's called data mining. So you are mining the data with the expectation you'll get something surprise. So with little bit of knowledge, you can do a lot. So that's the reason clustering becomes very popular, because many times you may not have training point. And if you have training point, definitely you won't go for clustering. Always you'll go for supervising. Now, last 10 to 15 years, deep learning. Why deep learning is so famous? I'm coming into that. But the idea is that deep learning is now using people everywhere. I marks only few, and we use quite a lot in medical domain and autonomous car, but people are using it everywhere. Why I'm coming to that? There is a good thing, there is a bad thing. I will come to that. And very interestingly, if your data size started increasing, okay, your data started increasing, and you will see that deep learning algorithm most of the time outperform any other. Why? Because today machines are very powerful. When I was a student, like, I mean, I saw that you possibly work with card punch. I never did, but our machine was 8086, 286, slowly. And today you talk about, I have right now I have a student in Stanford who is a professor. So he used to work in Intel, and that time Intel started believing that GPU won't survive for a long time. And you see today, NVIDIA is doing so well, and even Intel is in pressure. So new hardware is coming, new things are coming, and things are changing fast. So due to all this hardware, deep learning become very popular, because deep learning needs a lot of resources. Now, many students do one mistake. If I ask any student, most of the time they tell deep learning will do better. That's the reason we do. No, the answer is not that. Answer is that deep learning help you to find the feature. Correct. So in the earlier cases, what we talked about, we told that you know the feature. Knowing the feature, you are doing the classification. Whether it is supervised or unsupervised, doesn't matter. You know the feature. Okay, there is a very interesting topic I don't cover here. It's called principal component analysis. So if you know the data distribution, so using the data distribution, you can find a covariance matrix. And from the covariance matrix, you can find a eigenvalue and eigen matrix. Okay, eigenvector. So the eigenvector are the principal component, and eigenvalue will tell you which direction is better. So you can map your data into another direction. So PCA was there for a long time. but this is much new. Okay, and what they does, they find the feature for you. So basically, the main task of deep learning is feature engineering. The good thing is that you might not know the domain, you can randomly use it. The bad thing is that as soon as you fail, you have nothing to do with it. You cannot repair it. So difficult. Okay, so I'll show you. So today, I mean, so many techniques are available. I mean, every alternative months, new techniques are evolving. Okay, so you can download anything. So be very cautious. That I mean, in a university, even MIT, Stanford, you cannot develop a tool which is better than Google. Why? Because they have more resources. Until you have a huge resource, you cannot develop a new model by yourself. What you can do, you can use one existing model and then play around it. Maybe you can make it better. Otherwise, you need huge amount of resources. Okay, so that's the problem. So that's the reason now research is going more toward the industry. Earlier, it was in the academics. I'm talking about AI research. Going to industry is doing better because they have more resources. Okay, so now I will show you how to use some existing tool, and with little bit of modification you can do better. So this is one example. One of my PhD student was working. So this is a topic where we are trying to find the pollution of the city. So what the idea? Idea is that every car, when it is goes, at least in India, I think a little bit true in US also, they do some pollution. So can you find out which car is doing the pollution and which car not? Then automatically you can send a ticket if it is does a bad thing. Correct. So for that, what we did. So basically now we are talking about two class: car doing pollution and car not doing pollution. Two class problem. Correct. So what for the deep learning model, we use CNN and all this model. So what you want to do, what you need to do, you need to train the model with positive and negative. That means training point from both classes. So that means we need to train the model with car that is doing pollution. Basically, we are doing an image, correct? So you take a snapshot, and from the snapshot, you will have to tell whether that car is doing pollution or not. So you need a lot of training data, correct? So you need a lot of picture or image where the car is doing pollution and a lot of where the car is not doing pollution, correct? Both. And then from the picture, the model will started learning. Good thing or bad thing is that you never mention what is your feature. The feature will be generated by the CNN. So you Andrew Ian. So Andrew Ian is in my department now in Stanford. A very popular lecture is there. So you can follow one lecture, maybe you will understand it. Okay, very easy. If you have a class on filtering, it's like a, so what CNN does, if you have a 256 by 256 image, so they have a kind of window, 3 by 3 window. You shift the window and then it multiply and add. So basically summarization. So CNN one is called convolution, and convolution is followed by pooling. Pooling is basically subsampling. Okay, so you want to do speed up. That's the reason you do subsampling. Very easy. So you can use this kind of technique. Okay, CNN or anything. Now we in the Calcutta Road we saw two things you can do. Either you need real image or you need public image. So good idea is that mix both. You have a, if you have a public, use that at the same time generate your own image. So we used a lot of public images as well as image from our city, and we took the snapshot and we declared that this is your polluted, not polluted. You can do crowdsourcing also for that. Okay, if you do not have enough resources. And then finally, what we did, we never try to use our own model. So we noted so many models are already available, Inception, V3, and mobility is good because you can use mobile. Your mobile, you can take a picture, you can do the very light. That means mobile can do the computation, correct? And the other model you need at least not GPU, even CPU, running for 2 hours or some more than that. And most of the time, what people do for a huge computation, maybe you are taking the picture from somewhere, roadside camera or the car, you can put it in the cloud. The cloud can do the computation for you, and then it can go. The result can be sent back to you. But the thing is that that cannot be used for online. That means if you are thinking about that, I mean, accident of a car. That yesterday I was in San Francisco. I ride a car where there was no driverless car. Already, I think you already know. Yesterday I gone through that. So there it is risky because I mean you see that you do not have any time. You cannot send it to the cloud and wait for a 2 seconds, 3 seconds. That's the reason what people do is called edge computing. So you need to compute on the edge. Correct. That's the reason Tesla have a hardware chip inside the car. So you do not have time to send it to the cloud. If you have time, you can do, because like when we are doing medical application, I have some time. Okay, but I need to be very perfect. Okay, medical domain, mostly you have time. Maybe you can go for 10 minutes or half an hour, but autonomous car, very difficult. And then what we did, we used all the three models, okay, and then basically we try to, basically you have three experts, three teachers, and then you take the voting of three. It's called consensus. So every image we are showing three models. If it is telling polluted, we are sure that it's pollution. If all of them tell no pollution, okay, no pollution, correct. So in this way, it's a consensus. And another thing, very important thing, assume that initially what happened, most of the time when you were building the model, your training data set may not be very sufficient. So what you can do, for some images where you are very confident, they're test images, I'm talking about test images, very confident it is pollution. So next you can do a loop that you can bring it as a training point. Your test point can be a training point. If you are absolutely sure that it is pollution, okay, put it into a training point. So that means we are doing consensus, at the same time we are increasing our training data set in a loop. So this we did, very simple thing. Master student did it, and we got very good result, and already this paper is published in IEEE Transactions. Okay, if you are interested, I can see. So in the industry, people want that very quick result. Okay, so many models are there. I mean, nobody will ask you to develop a new model until and unless you are very good in maths. Developing a new model is not easy. Second thing, I mean, another interesting thing. So I was talking about CNN. What CNN does, I already mentioned that you have an image and you have a window. Every time the window is shifted, okay, by one. But if you do that, it takes huge amount of time. So nowadays, what people do, they have this kind of thing. So one is called stride convolution. That means you can give a jump of 2 or 3. Okay, so window is there, you just shift it by 2 units. It's called stride. And another for dilation. Dilation means in your 3 by 3 box, many places you can put 0. So if you multiply 0 by anything, it's 0. So that means you won't have to do that computation. So basically, deep learning, the computation is basically, it's a multiplication and addition. That's the reason the operation is called MAC. MAC means multiplication, addition, count. So this is the way we try to find the complexity of the model. So these two are there, correct? So stride and, but if you do, we saw that if you do a dilation of 2 and stride of 2, then it's very fast. But the problem is that you will lose 75% of the input information. That means your input image, whatever it was, you lost most of them. Your process is much faster because stride of 2, you are jumping the window by 2, and many places you did dilation. It is people do to for the speed up. Okay, so you check this one. So this is, you understand, 3 by 3 means matrix means I can think about vector of length 9, correct? So this is that, correct? So vector of length 9, and if many places are 0, that means you are doing a you are doing this dilation, okay? And jumping the window mean. So what we argued, I mean, so basically what you are doing dilation almost randomly. You are in the window, you are putting zeros and 1 randomly. So what we argued, don't do that. Rather, what you can do, you can, those who know a little bit of fuzzy, in the mid you can have a fuzzy membership function. Okay, that membership function will guide where to do the dilation or not using some threshold value. Okay, so that if you are good in fuzzy, you can, from the image you can compute that. It's a very easy. We put an intermediate state. Very easy, nothing. It's simply a fuzzy function which can help you to do the dilation, and you see the result. I mean, you'll be. So this is the whole network looks like. I'm not going into detail, and we are using that for during COVID. We developed that one. The task was to find from the X-ray images which one is COVID and non-COVID, correct? And I will go more and more. So you see the result. I mean, so if you go to our method, the proposed method, you see the proposed method is almost same like the base method. but it is much faster. You see how many parameters it is counting. Generally, deep learning model count number of parameters they handle is in million. Nowadays, we are talking about billion parameter. Like ChatGPT talked about billion parameter. But here, even simple model also take million parameter. But you see, just by doing that, your number of parameter count drastically goes down. Okay, so this little bit of trick you can do. Fine, and then you can, I mean, the existing model with little bit of trick you can do it much better. Now, another interesting thing I was showing, I just cancel that one. Today, if you do AI, that is not sufficient, okay, or ML, that is not sufficient. People are nowadays talking about trusted AI. Go to a company, only they will talk about trusted AI, or a part of trusted AI is explainable AI. Okay, so here let us talk about explainable AI. Correct. So assume you are trying to find the from the X-ray person is COVID or not. Okay, then what a good doctor does, expert doctor, they see some portion of the image. It's a lung, portion of the lung, image of the lung, some portion of the image, and looking to that, they are telling whether it is COVID or non-COVID. Now you are building a model. Model is telling it's COVID or non-COVID. Are your model is looking in the same place? That is very important, and that's the reason all these techniques are coming. One technique is old technique. In my lab, we have developed much better technique, but this is very standard. It's called GradCam. GradCam means, again, if you know a little bit of neural network. So basically, error is they push the error on the reverse direction, and the gradient descent is called gradient descent. Here also it's gradient descent. And here GradCam, what it is showing? It is showing my model is telling it is COVID and non-COVID, seeing the rest portion. It is localizing some portion of the image. Now you show some doctor for 100 cases, if they are satisfied, you will tell, okay, your image is better. Okay, so today AI or ML is not good enough. You need to have explainable. Either showing some picture, because at the end of the day, your patient, even a doctor doesn't know much about AI. Okay, so they are, in terms of AI, layman. So either you show some picture which very easily they can understand, or maybe use some language like what your language model does. In the below, in some doctor writes in the prescription they write. So I suspect you have this is because of this. So you need to write in a very lucid term, which a common people can understand. That is called explanation. And without that, no AI tools is accepted today. Okay. Now I will come into more interesting thing. There is another interesting thing. Basically, this is another CNN. Now this model, what you do, you started doing the error propagation. You wait to the end, and then you from the end you started going back. But what we told, every layer you do the feedback. Again, very simple thing. And doing that, here our idea was to find the, given a MRI, you need to find the tumor. Okay. So, and you see that this is our method, and the yellow means right, and if there is a red, that means wrong. Okay, and other models are couldn't do anything. Only very simple idea where we mention that do the error propagation in every layer, not from last to first. And very simple doing that, we are doing better. Okay, much better. But I will go to more, so you can see the result. Not important. But before that, I will tell you another interesting thing. So when I was talking about the COVID, so not only your AI also, you need more than that. In my lab, the best student right now I have, is very expert in AI ML. So his uncle has a infection, lung infection, and doctor suspected tuberculosis. India, still tuberculosis happened. And then finally, after 6 months, he died in lung cancer. It was expert, very expert doctor, and that person has tuberculosis. But doctor didn't realize that tuberculosis, if there is a tuberculosis, there is a chance of cancer. But if you go back, I'll show you. If you go back into the graph, I will show you some graph. Even your AI tool can tell. There is a possibility. So that is the reason. AI tool can be used to advise a doctor. Please check that. What a doctor mostly miss, because he was a very expert doctor. That person had tuberculosis, but in the background there was 6 months, after 6 months he died. If he can, at least it can be saved. Okay, even an expert doctor can do mistakes. I will come to that. So So now another interesting, I was talking about CNN, all this is graph, okay, because many data you can represent as a graph, like social network, okay, or biology, we do biological network, okay. And as soon as you have this kind of data structure, you can use another AI technique that is called graph neural network. If you write a code like I mean, when you transform language, you have a word to vec. Here you have node to vec. I know the representation, how to do it. I was learning from my son how to do the graph one, but it is not difficult. I mean, if you are writing for a program, the graph can be embedded, okay, in a vector form, and that vector can help you, okay. So this type of graphs are very important. Social network definitely important, even biological network also. I'll show you why it is so important, okay. So assume this. So this is a network. So this is called drug-drug interaction. So what is a drug? I mean, if you go back in your class 10 or 11, so drug is a chemical compound. Now assume that you have disease. Now when you are young, mostly you do not have a disease, but slowly you are becoming older and older, and multiple disease comes, and that is called comorbidity. Okay, you may have pressure with something, sugar with something, okay, and generally doctors give you maybe 5 medicine or 6 medicine, okay. So right now we have an Indo-French project. So in my counterpart in France, we have 3 hospitals working with us. We are trying to solve this kind of problem. So what happened? Assume a doctor give you prescription A, B, C, D, E, and among the 5 drugs, it may happen B or C is interacting with each other. Interaction is fine, but bad interaction is bad. If the interaction is bad, that will harm you. So can you tell the doctor, don't give B and C together, you replace one of them by another one, correct? So very easily you can do, okay? So for that, you need to have this kind of graph structure where every node is a drug, and if they interact, there will be an age, okay? And in the age, you can put some weight, I mean, interaction, whether strong or less, you can put everything, or positive, negative, you can write this, everything. So actually, it is coming from wet lab experiment. It's a wet lab experiment, chemical library or biological library, you can do that. But sometimes these experiments are very, very expensive. So what people do, assume that you have a subgraph. Can you predict? It's very common. Given a portion of the graph, can you predict that there are possibility of this stage? And if there is a high probability, possibility or probability, we'll consider that's a age, correct? So you can do also using a little bit of math, okay? So given a graph, can you predict new interaction, which is not tested in the wet lab? So new prediction, and if the probability is high, that means, so you understand it is very easy, okay, very easy to do this kind of analysis, and this can help a doctor as an expert system. And if you know little bit of biology, so the drug interact with the gene, and gene means mRNA, because our group is very strong in that. And then you can have multiple disease and pathway. So for my student uncle, if the doctor could visit the pathway, immediately they could realize. So the pathway, which later on we track in the pathway, and in the pathway it is clearly mentioned the protein or the disease, tuberculosis disease, and your cancer, lung cancer disease, there is a relation with the protein. So for a doctor, it is so difficult. I mean, how they will understand? So if you can go, if your machine or your AI engine can grow from here to the gene network to the pathway, then you have new information, and that can help a doctor at least.
So this only depends on your data set, right? So like there's social determinants of health for like a lot of studies are male based, right? So that's the data that's in the data set. Whereas like women aren't necessarily accounted for in particular studies with drug interactions, right? And so
It can change a lot. That's true, but at the same time, what we are telling, what happened? I mean, as soon as you are developing a tool in the medical domain, you cannot use it unless it is tested by regulatory authority. So what we tell, we can advise the doctor. So if you think that your male and female are different, you can have 2 different ones. You can do that, okay? So finally, what we are telling, we are advising the doctor to have a relook, and maybe that's a better suggestion for them. Many times they do mistake, but these tools are powerful.
there's no question that this is powerful, right?
Yes, it's powerful because you can very fast, quickly. For a human being, it's not possible. Why ChatGPT is so popular? Though it does so much mistake, because there are thousands and thousands of research paper, which you cannot read in 2 seconds. 1 second they can read and summarize to you. That's the reason they are powerful. They can do very fast. Correct. For a human being, it is not so easy because it's a huge network, and not only huge. The more difficult thing will happen. It is asymmetric. Only if you consider this part, this is symmetry, but then different type of nodes. So it's an asymmetric node. Okay. Even if you want to do vector encoding, you will find more difficult. So that's the reason. Don't go for graph neural network always. You can use simple graph algorithms. That is also like random walk. So for node encoding, you can use random walk also. So any simple graph algorithm you can use. Correct. Don't always go for very sophisticated because embedding is difficult. As soon as it is different thing. But definitely, if you have a database like that on the background, and if your machine or agent can search that, definitely it has more powerful than a common people. It can go into many depths, okay, from one node to another node, and so on. So with the French hospital, we are doing that, and we are getting very, very good results. Just day before yesterday, one of our IEEE paper, yeah. So we only talked about that, okay, how to handle this one. But it's very interesting too. I mean, you can do a lot. So, but today, basically, we are looking for a structure like that, correct? So, like, we are working with French, and I do not know about US. French, it is absolutely impossible to get any data out of France. So my students are going there, whatever model we are developing, we are doing that. So that means your data set can be public, can be private. It can be both. And your model needs to learn from both. You not only using always can have public data. Some data can be private. That's the reason your algorithm becomes interesting. So you need to run separate algorithm, and then you'll have to togetherly you'll have to treat it. But at the end of the day, now I'm coming to Professor Dasgupta's area. So in my French, I went to a conference last year. Even their medical system was attacked. So always there is a chance of attack. So that's the reason you need to be sure when you are talking about the whole system together, it should be blockchain and it should be protectable. Okay. Even in the company also, I will come to that. I will talk about that. So whole structure should be that, but make sure that most of the data set will be private, especially private hospital, they will never allow their data to go because those data are their business. Okay. As soon as you have data, today you see nobody talked about the model. Everybody is talking about the data. If you have data, you can be. So that data is very important. Model, there are so many models. Okay. So I already talked about that, and there are a lot of clinical. Now, why LLM important? I mean, so you see, as soon as LLM started, maybe 5 years back, everything changes drastically. It's a new addition. So OpenAI came with ChatGPT 4, and then Llama, our student is using quite a lot. Gemini, then last month DeepSeek. And DeepSeek, when DeepSeek came, NVIDIA share gone down. Why? You already know. This is much lighter. NVIDIA 17% share gone down. But we have I mentor one company in this area, and we also write our own algorithm. I mean, on language. The difficulty is that you cannot rely on all these algorithms because most of the time, so much hallucination. Why? Because in the internet you have wrong information also. So they are collecting information from correct one and wrong one. As soon as they are going to the wrong one, it's a hallucination. So much hallucination, you cannot use them. So what we find, and second thing is privacy preserving. I mean, when you want to develop any model, it should be privacy preserving and API attacks. Like, I mean, when you are writing a language model, you need to write a lot of API, and API attack is very common. So you need to think about that. So this is very important. What we understood after working almost 2 years, you need to write your own language model. You cannot depend on anyone's. Write your own language model in your own domain. So we are working in a narrow area of medical domain. So I do not need everything. So don't expect that my LLM model will solve every problem. I want my LLM model to be solve only problem related to cancer. We are working with cancer. So that's very narrow domain, but there you need to be very perfect. Okay. So that is fine. And second one, today we are talking about multimodal. That means not only from text, you need to talk about text and text together. And another of my student is working text, image, sound. So multimodality is coming. Not only text, text, image, text, voice, okay, all together. So multimodality is coming away. So if you want to work with LLM, so these are the important area where we talked about the security, talked about the attack, multimodality. People are doing a lot, and we understood domain specific is the key. If you do it for everyone, it will be in trouble. Okay, so this company we formed with our student. Actually, we were doing a lot of research last 20 years on genome and genome. We are very expert in analyzing genome. But then we started this company in 2000, 2 years back. The headquarters in Austin. And very young student will be happy to note that in 2 years, the company valuation is already 100 million. But we are doing the research. So one of my students was very excited to start a company 5 years back. We couldn't raise that amount of money. We came to USA, and our system is doing exceptionally well. So it is already tested in 5 hospitals in India, 2 in Bangalore, 2 in Hyderabad, and 1 in Vizag. Okay, already. So what we are doing, we are actually assume is, I mean, I'm just telling a little bit why the company is, maybe 5 minutes. Company is so successful. So generally cancer, when you have cancer kind of treatment, you need gene paneling. You need to understand some genes, how they are behaving and so on. Okay. So generally what panel nowadays available there is called panel for all the cancer. Correct. So necessarily it's a big panel, the cost is huge. So the sequencing cost is huge. So first we told that, I mean, don't go for everyone. You particularly think about 1 or 2 cancers. So our gene panel become reduced, so cost is less, and we can go more depth. That means what they cannot do, we can do. Correct. So that means we are talking about breast cancer and lung cancer right now. That means in these 2 cancer, I will beat everybody with very less cost. Understand? Because I'm not doing for pan cancer. This is first trick. And second thing, we load our own LLM. Why? What sort of LLM it is? Because as soon as a cancer patient is there, it is second stage or third stage. So regularly they need to have a monitor. So many doctors, alternative weeks, they sit together. It's called medical board. So we are writing our own chatbot to substitute that medical. That means if you have 20 doctors sitting, it's an expensive process. They will charge. So if your model, by what a doctor will do, they will do the past history and everything. Okay, what they did. So my model can also do the same thing. And then the doctors can get all things in their handprints. Okay, so I mean, and this is developed in my lab. Okay, very easy, not very difficult. But I told the key is you go for very small area domain specific LLM and write your own. Sometimes avoid writing API if you are threat of attack or losing something, because as soon as you call a API to a cloud, if your data go to the cloud, you lose your privacy. So these things you need to be very careful when you are running a company. Otherwise, you will be sued. They will take into the court. Okay, be sure that you are in the right moment. So it's working extremely well, and the doctors are surprised. So that's the reason. If you can use the LLM model in the right way, they do really good work. Okay, so I already talked about that. Today you cannot have simple AI. It is a trusted AI. One is explanation, explainability. Other one is fairness. Okay, something like you already understand. I mean, for the supervised, or maybe even if you are using deep learning, you have a lot of training data set, correct? And the idea is that your training data set will be unbiased. But those who are from India, they know very well that if I talked about the taxi driver in India, mostly it is male. That means my data set is already biased, naturally biased. Similarly, hospital, most of the nurses are women, correct? So it is already biased. So if your data set is biased, you cannot expect your model will be doing well, because model is trained on that biased data set. And I'm talking about the natural bias. There could be artificially injected bias also. Be sure. So that's it talking about. Robustness means not vulnerable to attack. Explainability already mentioned. Transparency means you are developing some model, company it happened, you left the company, another group came. Can they handle the same thing? That is the transparency. Privacy means data privacy is must. Otherwise, you may be sued in the court. Correct. Now, so trusted AI is the key. Now, I already talked about that. So today, I mean, so many AI things are coming. So I'm explaining, and data set also huge. Once again, you see what you do today. Okay. So when I was a student, I remember 97 from USA, I used to call my mom every minute $2. Okay. And today you are doing a video call hours after hours. Video you are sending, image, everything you are sending, all that. So our time, I mean, we are happy if you can do a NP problem to P problem. But today we are not talking about P problem. We are talking about constant time. That means I will increase the data. Your algorithm won't take more time. Your algorithm won't be a function of that data. Constant time, which is a huge demand. We developed one in our lab. Even Apache Spark kind of platform is also need to be updated for big data. So all these are coming into that. But you will be surprised to note, but many people may note, that Beethoven's 10th symphony is composed by AI. Correct. Up to 9 Beethoven did, and then 10 some pieces were there. And most of my friends who are very expert in music, they told they did a good job. So that means AI is good, not always bad, but you need to know how to do it. But be careful, because I'm just what happened to Google, you might know. Like, I mean, Google 2003 did a mistake. There was a woman with black color. Google declared it's a chimpanzee. Immediately Google shut down. So you understand, you can do a lot of mistakes. When initially my student was doing the CNN, this kind of model, they used to train two class problem, polar bear, non-polar bear, correct? And so that means you need to show a lot of polar bear and not non-polar bear. After that, you expect the model will tell you which one is polar and non-polar. And they found, surprisingly, whatever they are putting into the ice or snow, it is calling a polar bear. That means if anything, a dog in a ice is a polar bear. That means the feature, it did a bad thing. Feature was bad. It picked up feature wrongly. Snow was its feature. But how do you understand a polar bear? Maybe jaw width, length. Your feature should be correct. So nowadays you can develop a model where you can guide the model to find the exact feature, right feature. Okay. So 10 years back, when I was telling that Nobel Prize will come to the computational people, people are laughing. But today you see, last year you see. So all 3 Nobel Prize, all of them came to the, because machine becomes so powerful, you can do wonder. And we are very, very specialized in this area. This is a small molecular system which is on microRNA, not RNA. It's microRNA, and it is involved into many diseases, cancer. Okay, so we developed one of the fast computational microRNA tool in our lab 20 years back. Okay. So it was very powerful. That time that tool was used in USA also heavily. We developed in Kolkata. Okay, nothing. Whatever algorithm you are doing, AI or machine learning, you can sophisticate it a little bit, and if you have that domain knowledge, you can use it. So my last idea is that, so I will stop here, and the way you already know deepfake and everything. So AI is risky also. If you cannot control it, you will be in deep trouble. Okay, and deepfake, you know, the kind of video people generate, you cannot distinguish with the fake or non-fake. And today, most of the video that has been sent into the social media are fake. So don't circulate it, forward it, because AI audit is coming. 20 countries. One of my colleagues is a member of that. It's called 20 Kranti, and our Prime Minister is the chairman. And Europe, it is already there. That means as soon as you are generating a new video, you need to declare whether it is done by AI or it's natural. Okay. Otherwise, it can be penalized. I think USA and India also go into that direction, because you can generate a fake image, and in 2 minutes you can, in India at least, you can have a riot. Okay, social media, you can send it and people will believe it's correct, and it's a disaster. So very risky if you cannot use it rightly. Okay, and but at the same time you can get a lot of benefit if you can use like something like that. So first time I came to USA, I worked in Los Alamos National Lab, where atom bomb was built. and people are telling AI is more dangerous than atom. So if you don't know how to use it, you'll be in trouble. So that's the reason AI education in the school level also must. Education means not your LLM or all this. Like we have cyber education, cyber crime, cyber education. We need AI education also. AI audit is already done 20 countries, USA and India it will come. So these are a lot of my slide will be with you, so you can take the slide, and so anytime you have any question, you can come back to me. Let me stop because I think I take enough time. And definitely, you know that, I mean, at this age, mostly my student does work. So not only my Indian student, I work in different places. Now several Stanford students also working. So all of them, credit goes to all of them, not me. Okay. And I get a lot of money from this government. So yeah, so if you have any question, I can answer. Or anytime you can send me message. I'll be here for 2-3 days. We can meet and discuss.
Yes, again, first thank you for this wonderful talk. What I like about